Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques, and this is Simpler using machine learning algorithms in R. So we're in our final lesson for Unit 5 or Chapter 5, and we're going to be doing our model testing. So why don't we go ahead and move over to R, and we're going to just take a look at this real quick and see if we can wrap this up. So you can see right here that I just need to run my libraries again and set my seed. And so what we're doing here in line 5, again, we've already set up, we know what our coefficients are going to be, we know what our lambda, our alpha, all that is done. We're doing ElasticNet, and so we're going to wrap this up. Now, in line number 5, we need to set up our matrix because remember, I've already told you several times that the glmnet function does not like data frames. So in line number 5, we set up our test.matrix using the as.matrix function, and notice how we remove variable number 9 by using the brackets here to subset it. Because variable number 9 in that data frame was the dependent variable. We don't want that there. So we press Control Enter. Now in line 6 and 7, we are going to use our eNet. We made this model last time. We're going to use the predict function, and we're going to use our new data called test.matrix to create our object called eNet.y, which will have our predicted values. Remember, we're trying to predict how many days someone will be sick based on all the other information we have. Now notice how we set the lambda to 0.2 and alpha to 0.5, just like the kind of like the recommendation that we got in the prior video. So with that done, we can just go ahead and do our plots, our visualizations here in lines 10 and 11, and get the correlation in line number 12. So here's what our data looks like when you compare the predictions to the actual values here. It looks kind of like it, not the greatest here. This is the recommended line based on regression analysis. And then our correlation is 0.58, which seems reasonable, but there's a tremendous amount of error. You can clearly see this right here. Now, in lines 15 and 16, all we do is we calculate the mean absolute error, the square mean absolute error by taking the residuals here. So we take the predicted values minus the actual values, and then we square that in line 16. And we get the value 29.43. So whether or not that's good or bad, remember that depends on how we compare this to other models. And so again, as I've told you in other chapters, you now know how to do ordinary least square regression, lasso regression, ridge regression, and ElasticNet. And you could take the data set that we used here, the Vietnam Eye, and you can use those other algorithms to see which one has the least amount of error, which one does the best job at predicting. And again, by doing that, you can extend your learning into a practical situation. So that pretty much concludes Chapter 5 here. Now, if you are looking at the book, there's a little bit more about cross-validation. That'll be for your own reading. We're trying to keep the video simple here. This is the minimum you need to know to get started. But the ideas behind a more advanced form of cross-validation using the cv.glmnet function is for your own personal reading and for your own discovery and growth. So in this video, all we did was we used our test data on the model we trained in the prior video, and we did the visualization and looked at the metrics to see how well it was doing. That's essentially all we did. And we've done this twice before with Lasso and also with Ridge. So my name is Darren Thomas. I am the Director of Educational Research Techniques. This is Simpler using machine learning algorithms in R. Thank you.